this is chapter 1, models, measurements and vectors. So models are very useful in physics. If you have a complex system, to understand that system we can make a model of it with some approximations. Okay, so we use models to understand complex systems. And I told you physics is an experimental science. So we conduct experiments to verify theories. The measurements are important part of experiments. So we measure physical quantities using measuring tools, and also we study vectors in this chapter. Okay, so the main concepts in this chapter are units, unit conversions, significant figures, vectors. So we study here vector components and vector addition. Okay, so vector components. So these are the major topics in chapter 1. Okay, so you already know the units. Okay, so any quantity which can be measured is called a physical quantity. Now there are so many examples. So, and you know there are physical quantities are divided into scalars and vectors. Now scalar quantities have only magnitude and unit, but vector quantities have both magnitude and direction. Okay, also you will express units. Okay, so units are very, very important when you are writing a physical quantity. Okay, for example, if you just ask the height of a person, if the person tells you 165, it doesn't mean anything, right? But if you say 165 centimeters, then you have the meaning of that magnitude, right? So that's why units are very, very important. Now, you know, in mechanics there are only 3 fundamental physical quantities. Those are length, mass and time, right? So these are the 3 primary physical quantities in mechanics. Now the SI units of length are meters, mass are kilograms, time are seconds. And in CGS system, length unit centimeter, mass units grams, time unit seconds. Okay, now also let's do unit conversions. Okay, so to do unit conversions we must need unit conversion factors. Okay, so these conversion factors are in your formula sheet. Okay, so conversion factors. Okay, right. So we did an example problem in the previous video. Okay, let's do one more example problem. Okay, now this is problem number 4 at the end of chapter 1. Okay, so here the density is a physical quantity. It is scalar physical quantity. Okay, so the density of water is 1 gram per cubic centimeter. What is the value in kilogram per cubic meters? Mass units, SI units are kilograms, CGS units are grams, and volume units, SI units are cubic meters and CGS units are cubic centimeters. Okay, so volume is 3-dimensional quantity. Okay, now area units are meter square, CGS units are centimeter square. Now density is defined as mass per unit volume of the object or substance, right? So volume, mass per volume is defined as density of the material, and the density value is specific to a given material. Okay, here water density is given in CGS units, right? Because this is gram and cubic centimeter. Clear? So these are SI units and the CGS units are gram per cubic centimeter. Okay, so you need to learn how to convert from SI system to CGS and vice versa. Okay, so very important. So learn how to do the conversions. Okay, so here we need to calculate this value 1 gram per cubic centimeter in SI units, kilogram per cubic meter. Okay, so for this we use conversion factor. 1 kilogram is always equal to 1000 grams. Okay, because kilo is a prefix. If you look at your formula sheet prefixes, you will see 1 kilo means 10 to the power positive 3, 10 cube, which means 1000. Okay, so 1 kilogram is always 1000 grams. Also, if you write 1 cubic centimeter is equal to 1 centi, you see centi means 10 to the power negative 2. Okay, but you need to cube it. Okay, so you are cubing it and you have cubic meters. You see this is centi here. Clear? Understand? Now, so you can write this using the first power rule. You see first power, so first power rule, 10 to the power negative 2 whole to the power 3. So 2 times 3 is 6. So this is 10 to the negative 6 cubic meters. Understand? Now, so 1 cubic centimeter is always equal to 10 to the power negative 6 cubic meter. So using these two conversion factors, you can easily solve this problem. You don't have to memorize all the conversion factors, they are in your formula sheet anyway. So but you need to understand how to do the conversions. Okay, so let's write down. So density of water is equal to mass by volume. Okay, we use uppercase V to indicate volume. So this is equal to given 1 gram per cubic centimeter. Okay, so 1.00 gram per cubic centimeter. By converting this into kilogram per cubic meter, so I just write 1000 grams is equal to 1 kilogram, right? So I write kilogram in the numerator, 1000 grams in the denominator, because this way you can get grams gets cancelled, so you will have kilograms in the numerator. And you will write 10 to the power you will write 1 cubic centimeter in the numerator is equal to 10 to the negative 6 cubic meters in the denominator. So cubic centimeter gets cancelled, grams gets cancelled, so we will have kilogram per cubic meter, right? So now this is equal to, so this will be 10 to the power negative 3 in the denominator, so that becomes 1000 kilogram per cubic meter. Understand? So let me write this 10 to the power 3. Okay, so 1.00 times 10 to the power 3. Okay, 0.00 times 10 to the power positive 3 kilogram per cubic meter. Understand? So this is how we solve this problem. Okay, now that's the first part. Now the second part is the density of blood is 1050 kilogram per cubic meter. Convert this into gram per cubic centimeter. Okay, so you follow the same procedure using these conversion factors. You can easily calculate that. Okay, now the answer will be, I think, 1.050 gram per cubic centimeter. Okay, now next part C is how many kilograms are there in 1 liter bottle of drinking water. Okay, so to calculate this, so volume units are not only cubic meter but also the liters. So we need to calculate how many kilograms are there in 1 liter bottle of drinking water. Okay, so drinking water density is 1000 kilogram per cubic meter. Okay, so we need to find out what is the mass of this in kilograms. Understand? Now what is the equation that relates density, mass and volume? That is density equal to mass by volume. Understand? So here we need to find out mass. So mass is equal to density times volume here. Okay, we know the density of water in SI units. Okay, when you substitute the values, you need to make sure all quantities are in same system. Okay, so we are following SI system, so the density units are in SI system, but the volume units are in liters. We need to convert this into cubic meters. Okay, now I'll remember the conversion factor for cubic meters to volume is 1 cubic meter is always equal to 1000 liters. Okay, so for water, 1 cubic meter of water is equal to 1000 liters. Okay, so 1 cubic meter means you can understand this. I'll draw the diagram here. So let's consider a cube here. Okay, so this is, let's say, a cube. Okay, length. Okay, so length, width, height all are same size. Okay, so if this is equal to 1 meter, this is equal to 1 meter, this is equal to 1 meter. Okay, then the volume is equal to L cube, which is equal to 1 cubic meter. Okay, so you can imagine a cube with 1 cubic meter volume and fill it with water. How many liters of water will fill this cube? Exactly 1000 liters. Now we know 1 cubic meter is 1000 liters. So 1 liter is equal to how many cubic meters? So this is equal to 10 to the power negative 3 cubic meter. Understand? Now we have both density and volume in SI units. So let's write down mass is equal to density times volume. Okay, now density is 1000 kilogram per cubic meters. Okay, also we can write volume as 10 to the power negative 3 cubic meters. Understand? So this is equal to 1.00 cubic meter gets cancelled, kilograms. Okay, so 1 liter of water is equal to 1 kilogram of water. Understand? Now how many pounds is this? Okay, so how do you convert this into pounds? 1 pound is equal to 454 grams. Okay, so this will be 0.454 kilograms. Understand? Clear? So we need to convert this into pounds, right? So 0.454 kilograms is equal to 1 pound, 1 lb. So we need to write down 1 kg is equal to how many pounds here? Okay, so 1 kilogram times 1 lb divided by 0.454 kilograms. Understand? Kilogram gets cancelled, you get the result in pounds. Okay, right? So 1 divided by 0.454, so you will get 2.20. Okay, so 2.20 lb. So 1 liter water is equal to 1 kilogram mass, that is equal to 2.20 pounds. Clear? Right. Next problem number 7. You are considering buying a European car and want to see if its advertised fuel efficiency is better than that of your present car. Okay, so in Europe people use kilometer per liter for fuel efficiency. In the US people use miles per gallon, right? MPG here. Now you want to know if that European car is better than your present car. Okay, so if your car gets you 37.5 miles per gallon, how many kilometer per liter is this? Okay, so you need to calculate this in kilometer per liter. Okay, so once you do that, looking at this value, you can compare the advertised fuel efficiency of the European car and decide if you want to purchase that. Okay, right. So how do you do the conversions here? Using conversion factor, right? So this is miles per gallon. Understand? So we need to convert this into kilometer per liter. So the conversion factors are 1 mile is always equal to 1.609 kilometers. Okay, and 1 gallon is always equal to 300 gallons. Understand? So these are the conversions. Now, so here I am writing 1 mile is equal to 1.609 kilometer in the numerator, and 3.7, I'm sorry, this is not gallon, this is liters here. Okay, so 3.788 liters. Okay, so gallon gets cancelled, miles gets cancelled, so you do the math here. Okay, so simple, 37.5 times 1.609 whole thing divided by 3.788. okay, so you get 15.9 kilometer per liter. Understand? 15.9 kilometer per liter. You see, so this is the fuel efficiency of your present car. Okay, so 37.5 miles per gallon means 15.9 kilometer per liter. So you will compare this value with the fuel efficiency of the advertised car, European car. Okay, so then if the European car gives you better fuel efficiency, you might consider buying it. Okay, so that's the solution of that problem. Next problem number 10 in the textbook, chapter 1. So bacteria vary somewhat in size, but a diameter of 2 micrometer, you see this symbol here, that's micro. Okay, micro is a prefix. Understand? So micro means 10 to the power negative 6. Okay, so it's not unusual. What would be the volume in cubic centimeters and surface area in square millimeters of such a bacterium? Assume that it is spherical. Okay, now what do we know about sphere? Okay, now that's the radius of the sphere. Okay, now sphere surface area of a sphere. Okay, surface area of a sphere. So it's in your formula sheet. The formula is 4 pi r square. Okay. Now volume of a sphere is equal to 4/3 pi r cube. Understand? Now the only quantity we need to know is the radius. Okay, you can easily calculate surface area and volume. Okay, but careful with the units. We need to express volume in cubic centimeters, which are CGS units, and surface area in square millimeters. Okay, so square millimeter. Okay, right. So do we know the radius? We know the diameter which of the bacteria, which is 2 micrometer, right? So 2 micrometer, that means 2 times 10 to the power negative 6 meters here. Understand? So this is the diameter. Okay, so clearly write down, this is the diameter. Now the radius of this will be just half of this one, right? So the radius is equal to 1 micrometer. Okay, very simple. Now so do the calculation here. So 4 times pi times r value, which is 1 micrometer, but careful here, we need to write the value in millimeter squares. Okay, so you can convert this into millimeters here and substitute in this formula, or you can just calculate the whole value here and then finally convert the value into millimeter square. Understand? So you can write this in millimeters here. You know the radius value in meters, so you can write this in millimeters. So 1 meter is equal to 1000 millimeters. So to convert this value from meters to millimeters, we just need to multiply with 1000. Okay, so that makes it 1 times 10 to the power negative 3 millimeters. So now substitute this value in here. Okay, so surface area is equal to 4 pi times 1 times 10 to the power negative 3 millimeter square here. Understand? So you will write the value millimeter square. Okay, so understand? Now next here 4/3 pi r value, again 10 to the negative 3, but here we need to be careful. We need to convert this into centimeters here, not millimeters. Okay, now you know how 1 meter is equal to 100 centimeters. Okay, so now we need to convert this into centimeters here. That means we will multiply this with 100. Okay, so this is 10 to the power negative 4 centimeters here. Okay, so I am writing 10 to the negative 4 centimeter cube here. Okay, so careful with the unit. So this will be in cubic centimeter. Understand? So this is how you solve this problem. So the final answers are in your formula sheet for this problem. Okay, right. So the next topic is significant figures. Okay, so the very important significant figures. Okay, the number of digits we can read from a measuring device are called significant figures or significant digits. Now I will give you a simple example so you can understand what are significant figures. Okay, so I told you we use measuring tools to measure physical quantities. A ruler is a measuring device. It measures length. If you want to measure, let's say the length of a pencil marker here. Okay, value here is 8 centimeters, and this is 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 7, 8. This is 9 centimeters. Understand? So now what do you say the length of the marker here, the length of this pencil here? Okay, so it is between 8.3 and 8.4 clearly. Okay, so this is, let's say, 8.35 centimeters. Understand? Now another student might say 8.36 centimeters. Somebody else might say 38 centimeters. Now, did you notice all these three results, the measurement values, they have same value up to the digit millimeter, right? So this is 8 centimeter plus 3 millimeters, right? Now look at the 10th of a millimeter, the digit here. You see these digits here, 5, 6, 8, understand? Now these digits are doubtful here, understand? Because nobody is sure about these digits, right? We are just guessing between 8.3 and 8.4, clear? So because the length is not exactly 8.3, okay, it's little more than 8.3, so we are guessing that last digit, okay? So this is called doubtful digit, okay? And it is very important that you include one doubtful digit in your measurements, understand? Right? And you see how many all these three values are correct for the measurement, length measurement of this pencil, understand? Now, so we're talking about significant figures, right? So I told you the number of digits we get directly from the measuring device, in this case the ruler, okay, are called significant figures, okay? Now let's say the length is 8.35 centimeters. So total we have 3 digits, and these 3 digits we call them 3 sig figs. So 3 significant digits in this number here, okay? So this is how we find the number of significant figures, okay? So the number of digits that are directly read from a measuring device, okay? There are some rules to identify the number of digits in a given number, okay? So these rules are in your textbook. The first rule is the leftmost non-zero digit is the most significant digit always, okay? So in a given number, let's say you have this number here, the leftmost non-zero digit is the most significant digit, okay? So this is called MSD, most significant digit, and the rightmost digit is the least significant, rightmost non-zero digit is the least significant digit, okay? So this is the least significant digit, okay? And any digit between most and least significant are called significant, okay? So here total we have 1, 2, 3, 4 sig figs are there in this number, understand? Right? But in this number, did you notice there is no decimal point here, okay? So this is simple now, because you just look for the MSD and LSD and count the number of digits in between them, including MSD and LSD, okay? So that's the significant figure. For example, if you have a decimal point in the number, for example, you have 3502, okay? So if there is a decimal point, still the leftmost non-zero digit is the most significant digit. And when there is decimal point, the rightmost digit is the least significant digit, even if it is 0, okay? So in this case, this is the least significant digit, okay? For example, you have 0.35020, okay? So the leftmost non-zero digit is the most significant, and the rightmost digit is the least significant, even if it is 0, okay? This rule is when there is decimal point, understand? Now let's consider another example, 0.00320, okay? So in this case, the leftmost non-zero digit is the most significant digit, and the rightmost digit is 0. So do we consider this as least significant? Yes, because there is decimal point, okay? So this is LSD, and the digit between these MSD and LSD is also significant. So there are 3 sig figs in this number, okay? So here we have 1, 2, 3, 4, 5 sig figs here. Let's consider another example. Suppose you have 500, okay? So how many sig figs are there? Leftmost non-zero is 5, so that's the most significant. And the rightmost non-zero, you see there is no decimal, so you need to look for rightmost non-zero digit. So that is also 5 here. So 5 is the most and least significant digit in this number, okay? So there is only one significant figure, understand? Right? Now let's say I put a decimal point at the end of 500. Okay, now in this case this is the most significant digit 5, and this 0 here is the least significant, and this is significant, so total 3 sig figs. So the decimal makes a difference. This is how you identify the number of sig figs in a given number. Understand? So read these rules in your textbook and your lab manual. Okay, so next, when you do addition and subtraction, or when you multiply or divide, so you need to follow the rules of these significant figures. Okay, so here let's consider an example for multiplication division. So let's say you have 2.1378 and a number 7.21. okay, so you multiply this number in your calculator and see what you get. 378 times 7.21 gives you 15.413538. So but we don't write all these digits in the final answer, so we will write, so this is the result we got from the calculator. Now you see how many sig figs are there in this number? 5. How many here? 3. Okay, which is the least? 3. Okay, so the final answer should have 3 significant figures. Okay, but this doesn't have 3 sig figs. Okay, so we must write this final answer with 3 sig figs. So for this we just write 15.4. understand? So this is the correct value because it has 3 sig figs. And so you need to follow this rule when you are adding, multiplying or dividing. Okay, now let's look at the rule for addition and subtraction. Okay, now when adding, you need to look for the number of digits after decimal point. So let's say you have 5.232 plus 0.31. okay, so when you add these two numbers, you will get so this is 2455, right? So you are getting how many? 4 significant digits here. Okay, but you need to look for the number of digits here. How many digits here? 3. And how many digits here? 2. Which is the least? 2 is the least number. So in the final answer you must have 2 digits after decimal. Okay, but there are 3 here, so you need to round up to 2. So the answer should be 5.54 only. Okay, because 2 digits after decimal. Understand? So for adding and subtracting, you are looking for the number of digits after decimal point, and you need to keep the least number in the final answer. Okay, so for multiplication and division, you are looking for the total number of significant figures in each number and find the least value, and the result should have that least number of sig figs. Understand? So these are the rules for significant figure. Now let's do a problem. This is problem number 13 in chapter 1. Okay, so express each of the following numbers to 3, 5 and 8 sig figs. Okay, you all know pi is a mathematical constant. Pi is equal to circumference divided by diameter. Pi value, so it is 3.1415, right, and so on. This value is a constant. Consider any circle. Okay, so doesn't matter what the size. Okay, so consider any circle and you find the circumference of it, which is 2 pi r, divided by its diameter, which is 2r. Understand? So you will get exactly the pi value. Understand? So now, so the circumference to diameter ratio will always give you 3.14159265 and so on. Okay, so we now have this number here. So we need to write this number with 3, 5 and 8 sig figs. Okay, now let's write with 3 sig figs. Okay, 3 sig figs. So pi is equal to 3.14. Okay, so that's 3 sig figs. Understand? So you need to round up looking at the next digit, following digit. Okay, so let's write with 5 sig figs. Okay, so 3.1416. Okay, so this is with the 5 sig figs, right? Because you see this is first digit, second, third, fourth, fifth one. So the fifth one is just 5, but you see the following digit is 9, so you need to round up this digit 5, so it becomes 6. Understand? So similarly you can write the sig fix for other numbers. So this is another example here. Now let's do problem number 18, page number 24 in the textbook. The density of aluminum is given. So the density of this metal is 2.7 gram per cubic centimeter. Okay, so we need to find what is the mass of a cube of aluminum, that is 5.656 centimeters on a side. Okay, now let's draw a cube here. So that's a cube, length. So the volume of the cube is length cube. Understand? Now what is given to us? The side value is given. So length cube means 5.656 centimeter whole cube. Okay, so this will give you in centimeter cube. Understand? So you will find the volume easily, no problem. And density is also given, but careful, the value is given in CGS units, and here also we are finding it in CGS units. Now we need to express the final answer in SI units. Understand? SI units of mass are kilograms, right? So first you can just keep these values in CGS units. Okay, that means here gram per cubic centimeter, this is cubic centimeters, and just do the math. Okay, so density is equal to mass by volume. Okay, we are finding mass, so that is equal to density times volume. Clear? So substitute these values here, 2.7 gram per cubic centimeters times this number here, whatever you get in the calculator. Don't apply significant figures rules until the last step of the problem. Okay, so cubic centimeter gets cancelled, you get the value in grams. Okay, and then finally you can convert this into kilograms here. Okay, you know 1 kilogram is equal to always 1000 grams. Okay, right. So make sure the final answer is in two significant figures, because you see that density value has two sig figs. Here you may get more significant figures. Okay, but the least is two significant figures. So the final answer should have two sig figs. Let me go ahead and solve this. So 5.656, so cube of this is 180.9373. Okay, so 180.9373. Clear? So we substitute this number here. Okay, and then multiply this with 2.7. Okay, so I just wrote 180.9373. You can just keep more digits here. Okay, now you see we got 488.5 grams. Okay, so 488.53 grams. Okay, but we need to write in kilograms with two sig figs. Okay, fix, it will become 0.49 kilograms. Understand? So this is how we solve this problem. So I will explain vectors concept in the next video. Okay, so that will be the last concept in this chapter.